The directions ask us to solve or to graph using the slope-intercept form. So remember, the slope-intercept form I've written for you up top. And what we have to remember, and I wrote this important part down, is that we have to remember y must be by itself. So it has to be y equals something. And in this case, the slope-intercept form is the x term plus a constant, so mx plus b. M stands for our slope. Now remember, the slope is a fraction. It's a ratio of the rise over the run, the y values over the x values. Now, if the rise or the y values are positive, it tells us we're going to go up. If they're negative, we'll go down. Now, the bottom of the fraction tells us to go left or right. So if it's positive, we'll go right. If it's negative, we'll go left. The last part is the constant, and that is our y-intercept. And that's where it crosses the y-axis, and it's our starting point. And from that point, we use the slope. So let's take a look at a few problems that are similar to what you'll see. Here, y is by itself. So whenever y is by itself, we're going to use this slope-intercept form. So we're going to start with this number right here. That positive 1 tells us that we are going to start at that point. This is our y-intercept. So I'm going to go ahead and put a dot right at 1 on the y-axis. Now I'm going to use the slope. Remember, the slope is what changes the x values. So it is the coefficient of x. And so the 1, since it's positive, tells me to go up. The 2, since it's positive, tells me to go right. So from this starting point, from the y-intercept, I'm going to go up 1, and then to the right 2 spaces. Up 1, right 2. Up 1, right 2. I could also go the opposite way, because 2 negatives make a positive. And I could also treat this as negative 1 over negative 2, which would tell me to go down, because the y value is negative, and then left, because the x value is negative. So I'll start at that y-intercept, down 1, left 2, down 1, left 2, down 1, left 2. So with slope, we always have a consistent change in the y and x values. And so we've got our line, and we can draw a line through those points, remembering that we always want to extend that line past those points and put arrows at the end signifying that the line goes on forever in those directions. So let's take a look at the next one. We have a positive 3 for that y-intercept. So we'll go ahead and circle that positive 3, and I'll label that as my y-intercept. So I'm going to start up 3 spaces on the graph, put the dot there, and then I'm going to use the slope. Now remember, the slope is the change of y over change of x. So if you look at the number in front of the x term, the coefficient of x, and you don't see it as a fraction, you'll want to write it as a fraction. Now what number can I put down below to represent the same number? So I want negative 2 to equal negative 2 over 1. And then from there, any number over 1 is just that same number, because you're dividing by 1 in that case. So the negative 2 tells me to go down. But this is a positive 1. If it were a negative 1, the negative signs would cancel. And so that tells me to go right. So down 2, right 1 space. And you always go from the y-intercept. So down 2, right 1. Down 2, right 1. Down 2, right 1. But we could also go the other way. See, just one negative makes a negative. So I could go up 2, and then I could go to the left 1 space. So up 2, left 1, up 2, left 1. And I'd still end up on that same exact line. So we'll go ahead and draw a line through those points. Again, remembering to extend that line past the points that are there, and then also putting some arrows at the end signifying that the line goes on forever in those directions. Well, there's another one. This time we have another fraction as the coefficient, And we have a different y-intercept this time, a minus sign in front. So it's still that y-intercept. And the minus sign just tells me instead of going up from the origin, I'm going to go down 4 spaces. So 1, 2, 3, 4. And I put the dot right there. Again, that's always our starting point. So from that point, I'm going to use the slope, which is 2/3. And that 2 over 3 tells me what to do. So it tells me to go up 2 and then right 3 spaces. So from this origin, or from this point, this new origin, I guess, this y-intercept, I'm going to go up 2 spaces and over 3. So up 2 and over 3 spaces. And then I've got a couple points. I can also go the other direction. Remember, you can treat this as a negative over a negative because 2 negatives make a positive. So we could go down, but then we'd have to go left because they're both negative. So down 2, left 3 spaces also gets me on that line. So from that point, we can go ahead and draw the line between those points. Again, remembering that we always want to extend that line past the points and put arrows at the end showing that it goes on forever. Well, one more problem in part number 1, and that is an equation this time where we don't see a number out in front of x. So we'll talk about that in just a moment. We still have a y-intercept though. That y-intercept is -2. So we're going to go down 2 spaces on that y-axis and put a dot there. Now we've got this -x. Well, remember, you want the number in front of x. So remember, if you don't see one, you can always write a number in there. So we can put a 1. So this is going to be a -1 as the slope. And you can write -1 as -1 over 1. So the -1 tells me to go down. And then the positive 1 on the bottom of the fraction tells me to go to the right. And so from there, I can go down 1 and then right 1. Down 1, right 1. Down 1, right 1. But remember, you can always go the other way as well. So I could go up 1 and then left 1 space and be on that same line. So from this blue point, from this y-intercept, up 1, left 1 also gets me on that line. And you can see that slope again is always going to be consistent. It's always going to be the same ratio of x and y values. So from there, we can draw that line between these points, and we'd have our line. So those are a few of the different types of problems. We're going to go over one more part, which has problems that aren't quite in that slope-intercept form, that we'll need to modify the equation first and then put it in slope-intercept form.